In this lecture, I'll be covering externalities in markets. To begin, let's start with a review of some welfare economics. In the past, or at least up until this point in the course, we have been dealing with perfectly efficient markets. And how can a market be perfectly efficient? Well, if it meets all of our assumptions of perfect competition, which I won't necessarily list all of those here right now, because in a future chapter we'll look at those assumptions in more depth. The key assumption up to this point is that all of the costs and the benefits associated with this market activity are internal to this market. In other words, our demand function represents the marginal social benefit function, and our supply function represents the marginal social cost function. So we have a marginal social benefit curve, marginal social cost curve, and because all of the benefits from the consumption of this good are internalized, in other words, the consumers in our market are the only ones to receive a benefit from this consumption, then we can say that the marginal social benefit is equal to the marginal private benefit. And likewise, our suppliers, here represented by our market supply curve, they are incurring costs of producing this good. So the costs of the marginal cost of production, and those are also internal to this market. And so the marginal social cost curve equals the marginal private cost. And because of this, for whatever good this happens to be, we have an equilibrium quantity and an equilibrium price that is Pareto efficient. And we have producer surplus in the lower triangle, consumer surplus in the upper triangle. And so we can make a few notes here, just a few observations, that total surplus is maximized and that deadweight loss is 0. But this is no longer the case if there is some externality, the presence of an externality in this market. And what is an externality? An externality is essentially a cost or a benefit that falls on some third party, or we could say on a bystander. And this happens for all sorts of markets in the real world. So markets where you have a negative externality, that's a cost or some adverse effect of this market activity, this consumption and production of this good that falls on someone that's not engaged in the market. They don't buy the good, they don't sell the good, they don't impart ownership of the companies that are producing the good. They're just out over in third-party land, and they end up bearing some sort of cost as a result of somebody else's activity. And so examples of this would be markets where there's pollution or smog. So perhaps this is air pollution, this is the destruction of the environment, either the rivers and the streams and the lakes perhaps. This could be noise pollution. This activity results in some noisy outcome that others have to deal with. There are plenty of other examples that we could think of. And we could also think of positive externalities. A positive externality is some benefit that someone else receives without paying for it. So oftentimes examples like education or vaccines, or the restoration of historic buildings, etc., etc. These could be examples of positive externalities. So let's go back to our supply and demand model. And in this case, I want to examine a market that has some negative externality. And we'll imagine that this is our supply curve that represents just those internal costs, right? So this would represent labor costs, cost of owning and operating the factory, costs of raw materials and other inputs of production. And in this case, the supply function is equal to the marginal private costs. In other words, just internal costs for our suppliers. And as a result, there ends up, of this negative externality, there is a true marginal social cost curve that equals the internal costs, or we could say the marginal private costs, plus some external costs. Okay. And we have a market demand function. We're going to assume that all of the benefits of consuming this good for the buyers of this product are contained in this market. Marginal social benefit. Okay. Now, currently in this market, we are operating at this point. We'll call this Q1, and we'll call this P1. But unfortunately at this point, so at Q equals Q1, okay, the marginal social cost of this activity exceeds the marginal social benefit. And what would this indicate to you? This would indicate that we are currently in overproduction. In other words, we are producing too much. And where is the efficient market outcome? The efficient market outcome is that quantity at a quantity where the marginal social cost of this activity equals the marginal social benefit. And just looking at this graph, where is that point? Well, that would be this other intersection, right? This point here. Maybe we'll call this Q2, and we'll call this P2. So at Q2, this is our market. This is a point of production and a price where the market is efficient. At our current level of production, Q1, there is some cost that's being incurred by others outside of the market. So this is the size of our external costs, or our negative externality. Okay. Now, let's move to a case of a positive externality before we deal with how to solve this type of problem. Of course, there are many ways to try to solve that problem. Okay. In this next case, let's deal with a positive externality. I'm going to draw another supply and demand model. And in this case, we've got some demand function that represents the benefits that folks in the market receive when they benefit the good, but also someone else outside of the market is benefited by their consumption. So this could be like a vaccine where maybe it's a measles or mumps or rubella or whooping cough or polio or some sort of flu vaccine. I get some benefit by engaging in the market, by buying the vaccine. I'm vaccinated. Now I have perhaps a much lower, this depends on how many other people also get the vaccine, but I have a lower probability of getting the disease now. Okay, and so this demand function represents the marginal private benefits for those that decide to get the vaccine at various prices. And above that is the marginal social benefit curve. Of course, there is some supply function which represents our marginal social costs. So this represents all of the costs. There are no costs that fall on somebody else, right? When I get the vaccine, this doesn't, cause me to increase the spread of this virus. Okay. So now I want to identify that level of production and consumption that currently exists in the market. We'll call this Q1, and this is P1. However, at Q1, the marginal social benefit, which is up here, the marginal social benefit exceeds the marginal social cost. And what would this tell us? This would tell us that we are in underproduction. Currently, society is producing too little. Now, in our previous example, we'll just go back here for a moment. Society was producing too much. We could benefit by reducing the amount of this good that we're producing, and we'd benefit by raising the price. So we're also, in the case of a negative externality, okay, sorry for my sloppy handwriting there, negative externality, we are charging too low of a price. The explanation that I give in this case is we're charging too low of a price at P1 because there's some costs that other bystanders end up having to pay associated with the production and consumption of this good. And really, to correct for this problem, we need to do what's called internalizing the externality. We need to internalize this externality. Now, in this case, maybe there's some pollution that's running downstream and out of the factory and into a lake, perhaps. And so these people who enjoy the benefits of the lake, maybe fishermen, maybe folks who enjoy getting out in a boat and or swimming in the lake. Right now there's this pollution. Maybe it's killing the fish. Maybe it's ruining the water. And if the firm was to properly dispose of these toxins, these chemicals, or these pollutants, then that would raise the cost of their production, and some of that increase in the costs may be split between buyers and sellers of the good, and would certainly cause the price of this good to increase in the market. So in order to forego those additional costs and to be able to sell more and make higher profits, here we have a case where the self-interest of the firm, or perhaps the self-interests of the buyers and sellers in this market, are at odds with the social interests or of the interests of this third party. Here, we would prefer to have the market at this efficient point, Q2 and P2, because at Q2, the marginal social benefits of this good, of buying and selling this good, equal the marginal social costs. And currently, you can see here as well, we are charging too low of a price. So this happens to be the case, this one right here, this happens to be the case in both scenarios. But in this first scenario, it was because some of these costs are being offloaded onto others who don't benefit from the production or consumption of this good. Here, we're charging too low of a price, and this, I think, is a reflection of the fact that there's a free rider problem. So some people benefit, perhaps if this is the market for a vaccine, some people benefit from others getting the vaccine, because when someone else gets the vaccine, that's one more person, or I should say one less person, who can contract and transmit that disease to you. So I naturally get some sort of benefit, and if I don't choose to pay for the good, go out and get the vaccine myself, then I'm perhaps relying on many other people in society to get this vaccine, and if enough people, I meet a certain threshold, and enough people get the vaccine to where we've reached herd immunity, then the likelihood or the probability that I end up getting the disease with or without paying for the vaccine, there's a very small or maybe non-significant difference in the probability of me getting it with the vaccine or me getting it without. Okay. So in this case, we would like to be at Q2 and P2, but right now in the market, there is a deadweight loss due to this positive externality. In the previous example, we have a deadweight loss up here. Okay. So you can see this wedge of deadweight loss is sort of on the right-hand side of Q2. Here it's on the left-hand side of Q2. All right. Now, I'll come back to this graph here in a second, dealing with the negative externality, and we'll look at a few different policy proposals, ways in which the government has attempted to take care of or to solve some externality problems in markets. I'd like to talk for a moment about an economist named Arthur Cecil Pigou, or Pigou. I don't know, I've heard both pronunciations. Didn't know him personally. I think he was around in like the 18th or 1800s as an economist, so forgive me if I'm pronouncing that incorrectly. But there are essentially, from his work, these types of taxes. We can think of them as corrective taxes in the case of a negative externality, or sometimes you'll see these called Pigovian taxes. Okay. And the point of this tax is to internalize the externality. So let's go back to this case and remember what we know about applying say, an excise tax to this market. And in this case, I'm not really all that concerned with putting the tax on suppliers or on consumers, but in this case, I think it's just a little easier to think of this as a tax on sellers. But either way, we could work this out to get the same result. But essentially, for the Pecovian tax to be effective, the amount of the tax has to equal the external costs, at least when our supply function and our marginal social cost function are these nice parallel lines, because now I can see, all right, this distance here, maybe I'll use a different color, in yellow, this distance here, while they're two parallel lines, is the same, and maybe this would be the tax, right? This is the same amount as the amount of the external costs here, right? And although taxes don't really shift the supply curve, I want to think about this. This might be a little easier for me to think about a tax in the amount of the external costs that, at least on my graph, brings my supply curve with the tax, the sort of hypothetical supply function, up to equal my marginal social cost function. So that, of course, the excuse me, the tax incidence will be determined by the slopes of supply and demand. And in previous cases, we saw that this would create a dead weight loss in the amount of this little tax wedge here. But in this case, that's not going to happen because there's already a dead weight loss. We are in overproduction. So when the government places a tax on this good, that reduces, so here we move from Q1 to Q2, that reduces the equilibrium quantity of this good that's bought and sold in the market, and of course it raises the prices. And of course there's now a we'll say, well, maybe I should do this in a different color, but this green line here, this will be the new price that sellers receive. P2 will be the new price that buyers pay in the market. And there is a tax revenue as well that's generated from the tax. And perhaps the government could use that tax revenue to further regulate this market, or perhaps, regulated in the sense of imposing environmental regulations on the firm, or perhaps helping to cover some of the damages that were done to our third-party bystanders and so on. But now, this is an example where a tax has actually made the market more efficient, not less efficient. In this case, we've got a deadweight loss because of this positive externality that results from the fact that not enough people are being vaccinated. We would like to increase the quantity, and as a result, the price here is going to go up. However, we don't want to impose a tax in this situation. That's going to make the problem worse. Instead, perhaps, and in this case, many cases, governments will apply a subsidy or perhaps a tax break to folks in the market. And sometimes you'll notice this. I have a family member who's not as socially conscious about these types of things, and yet he at one point was telling me that I needed to go to Publix to get a flu vaccine because you get a $10 Publix gift card when you do that. I don't know if they still offer that, but anyway, you can change the costs and the benefits, the personal incentives that affect the individual, and as a result, you end up incentivizing more and more people to end up with the vaccine. And it'll be interesting to see how the government subsidizes, if at all, the COVID vaccine that is now being worked on, so as to make sure that producers produce enough of it, and to make sure that the price isn't too high so that consumers don't actually want to pay for it. So really quickly, we'll talk about a few other things that I want to mention. And perhaps, going back to a case of negative externalities, right? Suppose we've got a factory up here, right? A factory with some amount of pollution, let's say. Just ignore me, I'm not the best artist here, but this is a factory that's got some smokestacks, and this is putting all sorts of toxic chemicals. Maybe this is a paper plant, this is dioxin, out into the air, and there are folks in our town. I'm willing to make this artwork available for sale if anyone's interested. I know it's looking pretty good. And when they breathe in this dioxin, or are exposed to this dioxin, this increases mortality rates in the local town. It increases rates of cancer and other disease. Right, dioxin's toxic to humans. Meanwhile, the firm produces paper. So maybe we've got some factory workers here, and they're selling stacks of paper to our buyers. The buyers are paying for these products. Now, in this case, it actually might be difficult to come to an agreement on their own, right? The people in the town and the factory, they might not be able to come to an easy agreement because there are lots and lots of these people in the town, and maybe several different factories. Right? Maybe there's more factories over here. Okay. So this is a problem. Hey, would you get out of here? Go. Hold on one second. All right, sorry about that. The dog was making noise. Okay. So, there's a theorem that I want to mention called the Coase Theorem. And the Coase Theorem basically suggests that the private parties, if they can bargain without significant transaction costs, then they can solve these types of problems that result from externalities on their own. They don't necessarily need government to come in and levy a tax or levy a subsidy. However, there are a couple of problems that can emerge with that could prevent the Coase Theorem, or I should say, prevent private parties from solving the problems on their own. And that's if there are a large number of interested parties and if there are large transaction costs. And likely in this type of situation where there's a large number of bystanders, this will likely be an expensive legal dispute, and with there being so many people involved and such large transaction costs, it's very unlikely that these folks will be able to come to an agreement and bargain to resolve this on their own without some sort of legal mediation and perhaps even the government getting involved. But let's suppose that there's a factory that's dumping some chemicals into a local river. Okay. And this flows out into a lake. And we've got some fishermen here. Maybe a fishing community. And they're down here. They're typically happy to fish. These are my fish, if you can't tell. They're fishing. They make a living by fishing and selling those fish in the local market. Now, I've already discussed the reasons why something like this could happen, right? Because by not disposing of these chemicals properly, the business is operating at a lower cost of production. And it's possible, though, under the Coase Theorem, that if we just have two parties, maybe they've organized and they have a fishing agreement and maybe some sort of like a union, a fishing union, and so they've organized in some way to where the union over here can bargain with the firm. And because there are just really two parties here involved, so long as, let's say, the fishermen value the being able to fish out of the lake here at a price of, $600,000 a year, and the firm up here values being able to pollute at let's say 800, right? Let me change those numbers around, actually. We'll say that they value being able to fish at 800K. They value being able to pollute at 600K. Well, in this case, the fisherman can actually pay the firm not to pollute the rivers and the lakes, and so long as they arrive at some price in between 600 and 800, which they can do, right? Assuming there are no transaction costs here, then the Coase Theorem predicts that these two parties can actually solve this problem on their own, so long as the fishermen actually have a right to the property down here, right? Private property rights are necessary for this to work out as well. However, let's suppose that there are many, many people. There's also people out here on, little boats, right? Little sailboats, and they enjoy the benefits of the lake, and perhaps there are more people involved even still, then I would say, in this case, very unlikely that they will be able to come to an agreement, just because the number of people involved are too many, the transaction costs are higher, and if this lake is sort of public property or communally owned property, nobody has a particular or explicit ownership over the lake, then that could cause some other problems as well.